guys. My name's Rishal. It's my second time here at Rubyfuza. I love this conference. Even though I don't dev Ruby in Ruby, you probably hate me for that. I'm a solutions architect at Intellect, based in Johannesburg, where I help multiple teams, different technologies, different businesses, different contexts, solve problems. So in my past, I've been working a lot with platform development, mobile development across different languages, different technologies. And recently, in the last year, I founded a company called Prolific Idea, and that's the brand under which all my little pet projects sort of try to get built. So today I decided to speak about AI. Last year, about 10 months ago, I started the AI meetups in South Africa. So they're hosted in Joburg, Durban, and Cape Town monthly. And it's a topic that I've become a bit passionate about. I've always had an interest in it since academics. And I sort of lost track until recently. But the whole goal of this talk is to give you guys some insight into the current state of AI and hopefully encourage you to get more involved in that area. So to start off with, we need to ask ourselves, what is AI? What is artificial intelligence? So it's something very difficult to define, because when we started programming and when we discovered code and we could make something, calculate something with a few symbols, we thought, wow, that's really smart. A computer can do that. Or if a computer can make a decision using an if statement, that's pretty smart. Then a computer could beat a professional chess player. That's also pretty smart. A computer can find trends in data that we would never be able to pick up. That's also smart. But what's intelligence then? So is any of that artificial intelligence? Is all of that artificial intelligence? So the deeper question is, what is intelligence? And this is a more of a philosophical question. I'm sorry if the images are making you trip out. I really like them. So the formal definition, acquire and apply knowledge and skills, right? So that's the formal definition of intelligence. However, if you look at nature, you'll see various groups of organisms that we don't see as intelligent beings do really intelligent things as a group. It's defined by a form, in my opinion. So as humans, we think we're most intelligent because we're most dominant. And we're most dominant because we've evolved in such a way to preserve ourselves. Our primitive senses don't help us innovate in any way. Our eyes, our touch, it's all in our brain. So it's something we've evolved to do as an auxiliary function. It's not a primary function of us for survival, to innovate and be creative. Not everyone is a dreamer or inventor. So is AI something that learns? So something that is aware of past interactions and past conditions, has knowledge of that, has knowledge of the circumstances and context, and then can make decisions in future based on that? Okay, or is it something that improves over time? So is it something that has to grow? So is your if statement an AI? Or does your if statement have to evolve over time as the landscape changes? Does it need to make better decisions in future? Or is it something that creates? And this is a strange and interesting one, because creativity is a special kind of cognitive activity. It's not something everyone's great with. Certain people are, certain people aren't. But how do you measure that? How do you quantify that so that you can make a computer do it? And this is partly why I've got all of these weird images on there. That's from Google's Deep Dream algorithm. If you haven't heard about it, it's basically an algorithm that looks at different pictures and sort of dreams. In reality, what it's doing is it's working off Google's image recognition. If on Google, if an image is given to the algorithm of a car, it would predict, okay, this is probably a car. Excuse me. So what this algorithm is doing is saying, look at this image and I'm telling you there's a car in it, or I'm telling you there's a dog in it, and it'll find the slightest resemblance of a dog and put it in there and try and make it fit and say, this looks kind of like a dog. And what they've done is then feed it back into that engine to render this image of what it would look like to us. And that's why these images look really trippy. So that's the pillars of creation, but it looks like there's a dog and snails and things all over it, which is something really cool. But is this creativity? Is it something that it's doing that's creative, right? So let's say for now that we're just concerned with human advancement. The goal of artificial intelligence is to help us as humans advance, since it serves us best. So whether it makes us more money or makes the world a better place or helps people or helps a country, let's say that's what we want to build AI to do. Okay, so let's look at AI from a sort of stages of maturity perspective. If we look at artificial narrow intelligence, this is basically everything that's out there at the moment and everything we're currently working on. So the algorithm that plays chess, that's an example of narrow intelligence. Or something that can predict the shelf life of products, that's an example of narrow intelligence. So a story about that one, we actually embarked on a project for a company where we were trying to determine or better predict the shelf life of ciders and things like that on the shelf based on fat droplet residue after it's been produced. Because it turns out not everything from the same batch has the same expiry date, because not every bottle of cider has the exact same chemical composition. So that was very interesting from an intelligence perspective, where you're really making a valuable difference to a company with doing some really cool stuff with AI. But it's still an example of narrow intelligence. Okay, if we look at general intelligence, this is us. This is us as humans. We have a general understanding of different things, and we can use our experience on one topic and relate that to another topic. Okay, that's general intelligence. At the moment, we're not there with AI, with computers. And one of the big reasons for that is hardware. However, that's getting better. But we need to figure out ways for these different narrow intelligent units to be able to cooperate together, reason together. And then lastly, artificial superintelligence. And this, we don't really know what it could be. So some theories suggest that in the matter of minutes, if this is achieved, an AI would be exponentially more intelligent than all of us humans. So the point I'm trying to make is we set our own benchmark for what intelligence is. We don't really know what the possibility of it is. We only know we can be as smart as we are. Because we don't know of anything smarter than that. We don't know of anything more intelligent than that. So I don't know, will we be spared by the computers? So there's no limitation for constraints, no limitations or constraints for the uses of AI yet. It's not like, so you've heard a bunch of talks today, but in each of the different frameworks or concepts that you've heard about, there's always a reason to use them. There's a purpose for it. So why would you use a hammer to hit a nail? Why would you use AI? There's no clear answer to that. Yet, at least. So this is also a lot of thinking is going into this because it's becoming something more prominent in our everyday lives. And that's why there's committees being formed to sort of constrain what can and can't an AI do, to prevent this sort of AI running wild and doing things that might not be in the best interest of us. Okay, so for now, let's focus on narrow intelligence. So this is everything that's been developed now, as I mentioned. Let's not really think about general or super intelligence yet. Okay, so I'm going to go through some models and concepts about what your thinking is when developing an AI to solve a specific problem. First one, making a decision. So if I'm playing a game, do I make a specific move? If I make that move, what's the consequence of making that move? If I'm asked a specific question, how do I answer? So if you think of your virtual assistants like Siri and Alexa and that, they're making decisions every time you ask them something, right? Or making a prediction. So here's a picture. What's in the picture? Well, I'm predicting it's a mountain based on past experience. Or given these parameters you've given me, I think this is going to happen based on past experience, based on what I've learned. So it's making a prediction more than making a decision for sort of self-preservation. And then, tricky one again is reason. How do you get an AI to reason about things? Because we can weigh up options and we can connect our general knowledge and figure out, well, is this a good idea or not? So recently, an AI won a poker tournament, a no-limit poker tournament, and that's a big deal. So poker is a game where there's imperfect conditions. It's not like chess, where the rules are set and the moves are known. There's a lot of unknowns when you're playing poker. You don't know what the hidden cards are. You don't know what the bets could be, since it's no limit poker. And you also don't know what bets the other players could make before or after you. Well, after you. And this is huge, because if a computer can win that with this imperfect information and beat some of the best poker players in the world, that means we're developing a way for computers to reason about things and work with imperfect information much like we do. Another example is Google Translate. So they translate between languages, let's say English and Spanish, Spanish to Hindi, as an example. And what's happened is it's developed a sort of reasoning language within it where it can convert between two languages without using a language that we know as an intermediary. Okay, and we don't know what that language is. It's all in its learning and in its core. It now knows how to translate between these different languages in a language it invented, basically. So it could be a day where computers can communicate with in a means that we don't even know how to, right? And that's all about reasoning. It's about finding a deeper connection to relate different concepts and make intelligent decisions based on that. So if we look at some methods of implementing this, there's a whole lot of talk about old AI and new AI. And the whole idea of old AI was that you set heuristics and you set rules for the algorithm to follow. Whereas new AI wants the computer to figure out the rules by itself. It wants the computer to explore the given examples and figure it out. You don't need to provide the rules. Okay? So let's look at some of these examples of both old techniques and new techniques. So the first one is mimicking nature. So I mentioned that there's these different organisms around us that do intelligent things, and we can learn from them. So first one, genetic algorithms. So this is basically the concept of evolution. If you have certain sets of decisions that need to be made, you want to determine what is the most optimal set of decisions that should be made in a specific context. So an example could be stock trading. If the stock market wasn't as sort of volatile as it is now and there were trends, you could learn from the past and say, buy, sell, buy, hold, buy in that order at this certain time on the specific stock means that I'm going to make money, right? And the whole point is to evolve those sets of decisions to a point where you have the optimal set of decisions. And this is usually done through a simulation. You simulate this over generations and generations, and you find the strongest set of decisions or set of actions that are best for your goal. Again, it's mainly been used for narrow intelligence. Examples where you're solving a very narrow problem. Swarm intelligence, so if you look at birds, the formations they make, if you look at ants and how they collect food, these are examples of swarm intelligence. The whole idea is to look at how these things behave and how it can be applied to problems we have. So network routing, crowd simulations, pathfinding, these are things that some of these organisms do really well without being really intelligent in isolation. So when a problem like that occurs, like network routing, if you see traffic on the network as ants and you see the network as paths, you can use some of those concepts to help you. Next, let's say we want to mimic humans, since we are the smartest on the planet. Something like neural networks, and this mimics how our brain works, or tries to. Basically, you have a set of input nodes, much like we do. You have a set of output nodes to make a decision. And in between them, you may have varying number of nodes that influence the direction of the decision. So for an example, if you use a neural network, you could build one to maybe classify if a piece of text is English or German. And you could do that fairly easily. And then one that's been used quite a bit now is just use statistics, logic, and math. Right? So if you've looked into data science, statistics, that's basically the concepts that are being applied now for new AI, for making algorithms that learn from data, from finding relationships between different pieces of data, finding patterns in data, and making decisions based on that. Now, with all these techniques mentioned, you can always combine them. So you could have a genetic algorithm training a neural network to solve a specific problem, if it makes sense. Okay, so the whole point is that you need to combine these different techniques in some situations to achieve something, or sometimes to discover something new. So I liked the whole concept of metaphors and similes in the first talk, because all of these names we're giving to these algorithms, swarm optimization or particle swarm optimization and ant colony optimization, genetic algorithm, are simply labels we're giving to concepts so that we have a common language to understand them. Right? It's not to say that they can't be used together or adapted to solve a problem. So current users of these concepts and frameworks include things like natural language. A lot of work is going into that. So science, I gave you an example of something we've dealt with where we're analyzing chemical composition of things to determine shelf life. Okay. Agriculture, we're also doing some cool stuff in terms of bacteria in water. We're determining how much bacteria and what types of bacteria in water in certain conditions are going to kill certain crop types. And that's a really interesting thing to solve. And we're using machine learning to help us with that. And something like social media, if you're looking at things like chatbots, which are becoming quite popular. If you want to be able to service your clients without having a factory full of humans answering all their questions on Twitter, you could build something intelligent to do that for you. So there's lots of uses for these techniques. And I'd like you guys to look at what you're working on and see if there's potential to apply some of these concepts there. For now, I want to focus on machine learning. So I want to give you guys a brief introduction to machine learning and the basic concept of what classification is all about, just to pique your interest and hopefully get you to see that it's not as difficult as it may seem. Even though Google and all these big corporations are doing it, doesn't mean you can't. You can't tinker with it. So for machine learning, there's usually two different types of applications for it. There's classification and regression. So what that means is you want something to learn from examples and then classify things or put them into different categories. Or you want this thing to go and find relationships in data, vast amounts of data, and give you some insights into that, and learn from that, and adapt as it goes along. So here's an example of classification. The common one is the iris flower. So iris flower example is where there's a data set, and you want to build a classifier that can determine what kind of flower it is based on its petal length, sepal length, and varying properties like that. Okay, so that's a simple example of classification. Exploring what all flowers look like is something that's in the realm of regression. Right? You don't have a set goal to classify or put things into different categories. For now, let's look at classification. And as a toy example, let's look at password strength, since we could all probably relate to it. So the goal of this is just a simple example to take you guys through this toy. So password strength, if I showed you that, would you be able to tell me off the top of your head how those numbers got assigned to those passwords? It would be pretty difficult. It will take some time. You can't just look at it and tell. You may have questions that you want to ask. All right? So these are the rules I use to generate those passwords. If the length is greater than or equal to 7, give it 1 point to start off with. And then those other rules apply there. If it contains an uppercase and a number, 1 point, etc., etc. So as I said, that's with old AI. We would tell it the rules. And if we did, what's the difference between that and just building a decision tree with if statements in your code? We wanted to learn this. Okay, so after running that through a classifier in future, the classifier should be able to tell you the strength of a password without knowing the rules, but from building up a knowledge of those rules from all of the previous examples you've showed it. Right? Now, would it be able to do this by just looking at those strings? It would be very hard to just look at those strings and do it, much like we find it difficult to look at those strings and do it. So we need to look at the features of things. Okay, so let's look at this password in particular. What are the features of it? So we know it contains a lowercase character, it contains an uppercase character, it contains a number, and it contains a special character. And those are the properties we know of. Okay? So given prior knowledge of the rules, this may be satisfactory. But what you want to try and do is be more general. Instead of simply determining if that exists, here I'm counting the number of lowercase characters, uppercase characters, numbers, etc. This is more general, it's less restricting, it's more flexible. What if my rules changed? What if the length had to be more than 10 all of a sudden? Right? Give it the new data set with that rule applied to it, and it would learn it. And this is the problem. Although everyone talks about there being tons of data on the internet, tons of data generated every day online by everybody, the data structures that are used to support that aren't geared towards machine learning or artificial intelligence. When we're building software, we look at how do we design this database to make as most sense to other developers and support all of the features that the business requires. We don't think about how do we structure this database so that it can be used for machine learning later on. Okay? So you might have other projects that take care of that, but the main thing to understand is a big part of machine learning with data is preparing your data. And when you're preparing your data, these are the sort of terms that are used. When we said that that password there is of password strength 4, the label is 4, and we can't work with this raw password. This means nothing to your classifier in machine learning. This means something. All of the metadata about it. So these are called features, and features are mapped to a label. So I've put together a little bit of pseudocode, and it's literally this easy to get started with building a classifier that trains this exact example that we did. I've got a set of features, and there I'm just specifying that metadata for three different passwords, and I'm specifying the labels for each of them, and that's this password strength basically that you saw there. Creating a classifier and training it with the features and labels, and when I need to predict, I can just add a new set of metadata for a password and make a prediction. So I don't really understand what's going on in this train function. And the whole point is that you don't need to. You need to know what algorithms to use, when to use them, and how to use them. You don't need to know how they work. To do something valuable that has business value or value to you in the problem you're trying to solve, you don't need to know how this algorithm works. Unless, obviously, you want to create more AI algorithms, which is a different story. So the libraries I've been playing with and we've been using at the meetups is scikit-learn. That's a Python library. Python and R are the go-to sort of languages if you want to get into machine learning, artificial intelligence, data science, that kind of stuff. I do believe there are a fair amount of statistics gems available for Ruby that you can make use of and sort of build your own using those libraries. You don't have to have a purpose-built AI library for Ruby. So if you want to get started with that, it's still super easy. So I'd like you to take that and that simplicity of machine learning and classification and contribute to artificial superintelligence, because your contribution will matter when they take over, right? So that's the whole point of this short talk, is to get you interested in this topic and go play with it, because I'm really passionate about it here locally because people are doing great things internationally with it. I don't really see a lot of local developers exploring these concepts and this topic because it often seems very difficult and very intimidating, and people get sort of shied away from it. Okay, and that's it from my side. However, I've got some gifts that Intellect has sent down for some guys at the conference. I've created, I try to think of a little competition to run. So here's the Rubyfuza logo done with Google's Deep Dream. So we've got, you guys like Guardians of the Galaxy? So I've got this cool little baby Groot and a rocket raccoon, and the two best Deep Dream images based on Rubyfuza pictures will get these. I'll give them out tomorrow. So you could probably just tag Rubyfuza or something in your tweet with the picture, and we'll choose two of them. I've also got a bunch of these Google VR Google Cardboards. So I've got a bunch of these to give away. I'm going to put up a poll on my Twitter. You can just go to my Twitter, and the poll's not up yet. I'll put it up in a bit. But basically, answer the poll and maybe like it or comment on it or something so I know your name. And then we'll do a random draw for the Google Cardboards tomorrow as well. I think lastly, mentioned Prolific Idea. We just sort of got a little first product out. It's called HiveMind, collaborative mind mapping tool. Appreciate if you try it out. Give me some feedback. Be like beta testers for me. And yeah, that's it from my side. Thanks.